Hi everyone, in this video we're looking at surface area of composite shapes. So we're going to calculate the surface area of composite solids. You need to be, in order to be successful, you need to be able to identify and deconstruct the composite shape and modify your formulas to find those areas. Again, you're still substituting and stating the answer in appropriate units. So surface area, it's just these are three basic formulas that have been given to you from QCAA. We'll be looking at modifying those for composite shapes. So a composite shape is made up of basic shapes, and when you're dealing with surface area, it's important to account for those hidden faces. So you're either going to be subtracting them or like manipulating the formula to change, just to account for them. So it helps to recognize it helps to maybe draw a net and also recognize hidden faces. So with this first question here, what we have is two cylinders, essentially. I like to think of it as maybe like a rolling pin stick or something like that. If we have a look here, so it's saying it's closed at both ends, so that means that this surface here has to be included, and the surface on the end of this one has to be included. The one that we are actually omitting is this little bit of contact here between the two cylinders. Now, if we have a think back to what two cylinders are, it's two circles and the rectangle. Now, this little circle is going to have to be subtracted from this big circle, and it's going to have to be subtracted from the smaller cylinder here. So if I'll write it out of the formula, and you'll start to see that there's like, wait, there's a cancellation happening here. And then so I'll show you. So I'm going to call this 1, like cylinder 1, and this one here, cylinder 2. It's referring to the R's and from cylinder 2 and 1. So the other thing I need to note is that this is a diameter, so that's going to be 14 divided by 2 gives us 7, and 4 divided by 2 gives us 2. So there are our radiuses, or radii. So our surface area is going to equal 2 pi r1 squared, so I'm going to call that r1, and keeping the same formula, plus 2 pi r1 and h1, because it's coming from this cylinder here. Now I'm going to say plus the only one of those circles, so pi r, so that's r2. Oops, it's coming a bit 2 squared, and plus the other thing I'm noticing though is that I'm going to have to subtract that circle from here, so that means minus pi r2 squared. Now if you think about it as in like terms, so you know when you for variables, we can see that this is the same as this. So if I have 1 minus 1, the net overall effect is that they are negated or cancelled out. So I don't actually have to do more. So note that in mind, I can now do my solution. So equals 2 pi, the radius for cylinder 1 is 7 squared, plus 2 pi 7 times 10, and then plus 2 pi, the radius for my second cylinder is 2, which is 10. And then I plug that into my calculator, which I can do just as it is, and the answer is going to be then 873.36 millimeters. That is how I can get around that. Now, some of you might prefer to break it down into each component. So if you did like 2 big circles, and you would do the FSA big rectangle, then you would have your FSA, and then small, and so forth, FSA, and you won't actually do your small circle. So just try and minimize how much calculating you're doing, because the more you do stuff, the more errors you're going to get, because more opportunities for errors to emerge. Sorry, you're not going to get them. It's just more opportunities for errors. So what's going to happen is if you're rounding, that might also impact your answer. So just keep that in mind. That's why I've tried to do one major formula and modify it, and then substitute in accordingly to that formula. Your calculator is pretty good at handling that type of stuff. So having a look at this question here, so it's actually a bit of a worded problem. Greenhouse is constructed as per the dimensions in this one here. Calculate the area of plastic required to cover the walls and the roof of the greenhouse. So that's the part where you need to be aware of, like, well, there's hidden areas that, or surfaces that don't need to be included. So one of those areas would be the interface between your half cylinder, your semi-cylinder, and the rectangle roof. So that doesn't need to be included. Your floor doesn't need to be included. So that means that we're breaking this down into rectangle 1, and there's another one over there. So which means that there's also 2 R2s. You've got this semicircle here and another semicircle here, so that essentially just makes 1 pi r squared, so 1 circle. And we've got half a cylinder, so we're going to actually work out the full rectangle and then divide that by 2. So there are all the components of the surface area that I have here. So as a formula, write that as surface area equals. Before I get started, for those people who are more inclined to go each component, yes, you can do that, as long as you clearly label and state what you're doing for each, so communicating effectively. So you might be like, here is the area for 2 of my rectangles, then here is the area for 1 of my 2 of my other rectangles, here is the area for the circle, here is the area for half a cylinder, and you're welcome to do it that way. Again, just be mindful, it is a risk in terms of making an error, because you're doing multiple calculations, and then the other thing is rounding errors that may come up. So surface area is going to be 2, and I'm going to call that L1 W1, so length times width, L2 W2, because that's the second triangle I'm looking at. Sorry, rectangle. Did it again. And then we're going to go plus pi r squared. Oops, it's 2 pi r h divided by 2. And that's going to give us our half cylinder rectangle that makes up that roof, because I don't need to go down, because I've already accounted for that in my rectangle here and on the other side as well. So like substituting my values in, one of the things I didn't do earlier here was r. So if this is your d, it's going to be d over 2 gives us your r. So that's 3, 2 equals 1.5. Okay, so surface area equals. So I've substituted in my values. So this one has come from my first rectangle, so the dimensions are here. So the 1.8 is the height of this rectangle, and it's also the 1 is that rectangle, so that's there. Then you've got your 1.5, which is your radius, and the 7, which is the height of the cylinder, divided by 2. So again, your calculator is pretty meaty at getting that in, and you are welcome to just punch it through all in, and that would give you a 59.56 centimeters squared as your surface area. Oh, whoops. Sorry, meters. Meters squared. Checking my units. See, that's what we need to do in order to be successful. Select the appropriate units for your question. So then I would state my answer back in a statement. One of the assumptions would be here is that there's no like seam allowance or wastage material, and we'll talk about those a bit later on in another video. So assuming that it's just exactly like perfectly the pieces are there, it's like this is how much greenhouse plastic you need, which is 59.56 meters. Okay. You've got homework questions that align to all of this stuff, and these are the questions that we'll be looking at in class. All right, thanks guys.